In an AC circuit, the cosine of the phase angle between voltage and current is called the power factor, which can also be expressed as the ratio of active power P to apparent power S. When the load is resistive, the phase difference between voltage and current is 0, and the power factor can reach 1. Other loads' power factors range from 0 to 1. Improving power factor fully utilizes generation capacity and significantly saves electrical energy. It is necessary to ensure the reactive power required by inductive loads while reducing the energy interchange between the power source and the load, which is the practical significance of improving the power factor. A common method to improve power factor is connecting capacitors in parallel. This is an inductive circuit without parallel capacitor. Its vector diagram shows current IE as voltage divided by impedance magnitude and power factor as resistance divided by impedance magnitude. We connect a capacitor in parallel, which generates a current IC. The sum of IC and IE equals the current I, and the current IE remains unchanged. Connecting a parallel capacitor significantly reduced line current and altered its phase difference with voltage from angle FNE to angle F. The power factor has been improved. The line current is reduced, active power remains unchanged, and reactive power drawn by load from source decreases. The reactive power for inductive loads is mostly or entirely supplied by parallel capacitors. The current IC provides reactive power to the load, thus it is also called reactive compensation. This way, the power source can supply less reactive power and more active power, allowing the capacity to be fully utilized and reducing power loss on the lines. Improve power factor by connecting capacitors in parallel. Thanks for watching, friends. Bye.